Okay, everybody, welcome to the second video lesson of our experiment. This video lesson will be consolidating the concept of similarity in triangles specifically. And in order to consolidate our understanding, I think we should call in an expert. So, hey, Griff! There he is. Nice picture. So we come from the concept of congruence, and we're sort of graduating to the concept of similarity. From congruence, hopefully we understood that two congruent figures have exactly the same measurements, shape, size. And now in similarity, what we're looking at is that we can have sort of the same shape of similar size. So that obviously didn't work. That would be a different figure. This guy here, if I proportionally enlarge Griff's face, then we have a bigger version of the same Griff. And that's sort of what we're looking at. More Griff is always better, so that's good. We asked you to sort of discover this by looking at some triangles. The first task in the discovery was to look at these two triangles, and we asked you what relationship you might have seen between these two triangles. I think it's fairly obvious. Hopefully you reached the conclusion that these two triangles were exactly the same shape, but one was bigger than the other. So when you found your measurements, you might have found that corresponding sides were proportional and corresponding angles were congruent. And we're going to get into this concept in the next slide, but really what the gist is that angle D and angle A correspond and are congruent. Angle C and angle F correspond and are congruent. And angle E and angle B correspond and are congruent. And then if you took the measurements of those sides and found the ratio, you'd have that they were proportional. The next set of triangles was a little different. It was presented to you in such a way that it wasn't so obvious to recognize that they were similar. A very important strategy when you're looking at similar triangles, especially in certain drawings that are more complicated, it's to redraw or reposition those triangles so that their orientation is the same. It becomes really a lot easier to see which sides correspond with which sides and which angles correspond with which angles. And again here, hopefully, when you took your measurements, you came to the conclusion that corresponding angles are congruent. So angle H and angle B, were congruent. Angle A and angle U were congruent. And angle M and angle D were congruent. Next step was to measure the sides, and hopefully, again, you reached the conclusion that measure of side AH over the measure of side UB would give you the same ratio, or would be an equivalent ratio, as the measure of side HM divided by the measure of side BD. And that will give you the same ratio as the measure of the two remaining corresponding sides, which were AM and UD. Now what's important, I think, to recognize here is that these ratios are set up such that the smaller triangle is on the top, or in the numerator, and the larger triangle is in the denominator, and that's consistent for each one of these. And really, we could have switched them. We could have had the larger triangle over the smaller triangle. As long as we maintain that consistency throughout these ratios, then we're going to be okay. So really, the conclusion that we hoped you would reach, there were two parts to the conclusion, but basically that similar triangles have two very important characteristics. They have congruent angles, or congruent corresponding angles, and proportional corresponding sides. Let me scroll down to make sure that fits, and we're good. So that's the conclusion we hoped you reach.
Please excuse this interruption.
Excuse this interruption.
Please see Mrs. Perdikas at reception or
So,
call extension 7210. Mr. Canuel, please contact reception. Thank you.
the next step that we asked you, or the next task that we asked you to look at, was this triangle where hopefully you saw a couple different triangles, or more than a couple. Certainly, there's the big triangle that you would see that you'd be able to pull out from there. There's going to be sort of the middle-sized triangle, and there's going to be the small triangle. So hopefully you're able to see the small one, the middle one, middle size, and the larger triangle. And so within that drawing of these three triangles, we asked you, are those three triangles similar? And when you bring them out like I suggested in the previous video, and you put them together or you draw them out so that their corresponding sides are in the same orientation, what I hope that you're able to see is that they appear to be similar. This appears to be the same shape as this, just smaller. This appears to be the same shape as this, just smaller. And so we then have to sort of ask ourselves, and I think this comes naturally after we've done congruent triangles, is how do you know? And what we know about similar triangles is that their angles have to be congruent and their sides have to be proportional. And so maybe the logical step that you followed was that you took your protractor and you took your ruler and you started to measure. That's what we had you do in the first two tasks. And I would think they would be okay at that point to do the same for this task. And I think you found that they were, if that's in fact what you did. But the next step is, can you actually do that without the use of measuring tools? And this is sort of um, the real end goal for this talk is, can you show without the use of measuring tools that two triangles are similar? What sort of conditions do you need? So in order for us to do that, to show that, the really important piece of information that's given to you is this. And those mean that these segments are, my thing just froze, parallel. And because those are parallel, we're able to make a couple statements. Because there's no measurements for the sides that are given to you. There's no even angle measurements that are given to you in terms of numbers here. So without the use of measuring tools, we have to be able to use angle relationships to make this claim that those triangles are similar. This thing keeps sticking on me, so you'll have to bear with me. Please obviously feel free to pause the video, go back at any time. So we're looking to use angle relationships to show that those three triangles were similar. Remember this? The idea here is that from grade, I think even grade 7, we started to look at the relationship between angles when two parallel sides are intersected with what we call the transversal. What we saw in these drawings was that this angle and this angle were said to be congruent when these two sides were parallel. The relationship that they have is that they are angles that we call corresponding. And since corresponding angles are congruent, when two parallel sides are intersected with a transversal, we have some really important and really useful information to use in answering this question. So if these two sides are parallel, this line here, this side of the triangle, acts like that transversal. And so what that means is that this angle, and this angle are all the same by nature of them being corresponding. And so that certainly helps us try and determine if those triangles are similar, because we need to be able to prove or show that those triangles have congruent angles. If you look at this side of the triangle, you have again a transversal with parallel sides, congruent angles, by nature of them being corresponding. So now we can see that each triangle has a pair of corresponding congruent angles. So that's almost enough in order to prove or show that all of the angles are congruent. but maybe it's enough to show that in general. So let's look at the next step. The next step is going to be that there are some minimum conditions for showing similarity of triangles. And really, when we think of minimum conditions, we just came out of minimum conditions for congruent triangles, and so this leap, I hope that this is a little bit um, obvious to you in the sense that we're going to look for the least amount of information necessary to show that two triangles are similar. Remember that similarity means angles are congruent and sides are proportional. So in this first drawing, what we see is the information given that this angle and this angle are congruent, and this angle and this angle are congruent. And so because we have these two angles are congruent, we have enough information to suggest that those two triangles are similar, and the minimum condition acronym that we have is called angle, angle. I don't need the third angle to show that all three angles are the same, because if I know that all three angles in a triangle add up to 180, and these two are the same as each other, then I know that that third one will be the same as well.
Interruption with Nadia Facciolo. Please report to room 255.
If I look now at this second set of triangles, if I look now at the second set of triangles, I can see that there's another minimum condition suggested here. And that if I look at these triangles and match up corresponding sides, I might be able to see that the 9 and the 6 match up, the 7.5 and the 5 match up, and the 6 and the 4 match up. And if I were to reduce all of these ratios, I would get exactly the same ratio, which is that 3 over 2 is equal to 3 over 2, which is equal to 3 over 2. So what I found here is that when all three sides, all three pairs of corresponding sides are proportional, then I don't need to know anything about the angles to show that those two triangles are similar. And the acronym for that is SSS. Third situation, and last one, very similar to the congruent minimum condition. We have here sides that correspond and are potentially proportional, angles that correspond and are congruent, and sides that are corresponding and potentially proportional. What we need to do is to ensure that those sides are proportional. And since those two ratios or proportions are in fact equivalent, then we can say with certainty that those two triangles are similar by reason of SAS. So hopefully that helps you understand the minimum conditions for similarity. Hopefully you had a good time and had some enjoyment out of this video, and see you in class.